So I'm going to start with the multiple choice on the stoichiometry test review. I may not even get to balancing equations. The reason I'm starting here is that it actually explains some of the reasons we're doing something instead of just showing you why we're going through films. So this is one of the things. This is the question, right? So here's my question, and here is the beginning, which is actually a different substance. So we've talked about using the mole roadmap. We're going to start with mass. So we're starting here. This is the given substance in the problem. This part's mass, this part's moles. And then here's where you're going. This is the other substance in the problem, and we're going somewhere else. We're actually going down here into moles of a different substance completely. So when you use the mole roadmap, this means that there are two steps, one step, two step. So that's this answer. So each problem can be followed by the mole roadmap each way. And I know that some students get frustrated with using the mole roadmap because it requires learning how to use a certain tool, and they'd like something a little simpler. So this is as simple as I can make it. There's a starting amount and an ending amount. In the problem we were looking at, the starting amount is mass or grams. So we're starting with grams, and we're going to moles. And we were changing the chemical formula, so it would take two steps because we'd have to use molar mass first, and then we'd have to use mole ratio. Again, that's in your notes. There's a whole set of notes, but then there's the decision tree. So here's another way to answer this problem. All right, going on to number 2. That took 2 minutes. Crazy. Okay, with this problem, where again, our job is this is what we want. We want moles of chromium is where we're going. So we're going down here. And we're starting with grams of O2. So that's where we're starting. So where would we go with this? And that is use molar mass in your first conversion. So we're going to use molar mass in our first conversion. And then in the second conversion, it's here. Let's go ahead and use pink. This time it's a mole-mole conversion using molar mass. And so that's a mole ratio. So we'll want to choose C for this. So I didn't list this as mole ratio. I said using coefficients because it's the most difficult thing I have is to use these pieces when you're doing a mole ratio. Okay, let's look at what the decision tree said. And the decision tree, remember this is exactly the same. It says use molar mass, then use mole ratio. Use molar mass, then use mole ratio. So we end up in the same spot. This might be a little faster, but there we go. And I just talked about this one. Coefficients are these whole numbers, and these little numbers could be on the test. These little numbers like 2 and 3 here, those are called subscripts. Subscripts. Okay, which we covered a while ago. Number 4, let's bring our mole roadmap along with us. The ratio that changes substances. So in that case, how do I get from one substance to another? It's right here, down here at the bottom. I guess I can enlarge this. So only down here can you change from A to B. A being the given substance and B being the substance you're going to. And you'd never do it through mass. You don't do it through liters. You can only do it through the mole. So only through moles. On this, if we are changing the chemical formula and we go from moles to moles, which was basically here, was that part of the problem. It's a one-step problem using the mole ratio. So that one's right here. Okay, next, units of molar mass on your notes. This is a discussion of molar mass. Molar mass is moles over grams, and more often it's grams over moles. So everything about molar mass is discussed here in your notes. So grams over moles are units of molar mass. Okay. Moving on. Which of these problems needs two ratios to solve? So on a mole roadmap, it's like, well, I have to go from two places. One of the things you can think about is how many changes did you make? In A, I changed from mass to moles, but I didn't change oxygen. Oxygen stays the same, so I only made one change. So how many ratios do I need? One ratio, because I only made one change. Here, I'm going from moles of H2 to moles of O2 to moles of H2. This time, it's the moles that stayed the same, and it's the O2 to H2 that changed. How many changes did I make? One change. How many steps? One. But if I change both of them, if I change both the moles to grams, that's one change, and I change the oxygen to hydrogen, I've made two changes, and that's two ratios. This is dimensional analysis. Like, dimensional analysis is this method. Let's see. Right? I'm trying to go, okay, so grams should go here. That doesn't work. You always have, right? They're always a diagonal. So this one would go here, and now this one works. This one goes here, and then this one, oh, I should change colors. Sorry about that. And this one should go here, right? So as we go along, we're changing the unit, and so we're doing a canceling thing all along. Here it works. So grams goes to grams, and moles goes to moles, and hydrogen goes to hydrogen, and grams goes to grams. So this is a good one to say this one works. This one works. And this one works. So the next three work. So each of these actually has a specific set of numbers. So for a molar mass, for molar mass, you need this to be 1 mole. So whenever you have grams, this should be 1 mole. So we're going to look for that. That doesn't show up here. Whoa, sorry about that. That doesn't show up here. And that's it. So this one doesn't work because it's not 1 mole for the grams. This is 1 mole per gram, this is 1 mole per gram, this is 1 mole per gram, this is 1 mole per gram. The grams come from the periodic table. We're going to assume that they're all right, and they are. So our last two, remember this one didn't work because it says 2. So now we're going to get rid of this one, we're going to get rid of this one. Here, the only difference is, should I have a 1 on top or a 2 on top? So where do mole ratio values come from? Mole ratio values come from, oh, I can't see. Mole ratio values are coming from the balanced equation. So here's a mole ratio, and that came from the balanced equation, and I don't see any more. There must be one. Mole ratio right there, mole ratio right there. They're coming from the balanced equation. Here, I just need the ones from the balanced equation. So I need a 2, get a 2, and a 1. Sorry, that actually took too long to talk about. But here there's no 2. So you have to go through this kind of problem much more slowly to make sure that you're getting it. And notice I didn't use the mole roadmap for this. I could have used the notes up here on what is a mole ratio, and it tells you how to do a mole ratio. But really, the idea is first you do the dimensional analysis check, then you check to see if you have 1 mole for each of the molar masses, and then you finally check to see if you have the right coefficients. And I suppose there was one more mistake that could be you didn't add the molar masses together correctly. This equation is partially balanced. What's the next step? So here we see we have two ends on both sides. And if I counted oxygens, let's see, sorry, I'm changing colors. I have 2 oxygens, and I have 2 more oxygens, and I have 4 oxygens on this side. So the oxygens are balanced. So the thing that's not balanced is hydrogens. I have 4 on this side. I have 6 on this side. So 2, let's undo everything. So I have 2, so I have 6 hydrogens on this side. And I have 4 hydrogens on this side, and the only place I can get hydrogens is here. So I really need to add more of this, and that will cause it to increase the number of hydrogens to 6, and I'll be okay. Now, did we balance everything? No, we screwed up the oxygens, but in this one, we're only asked for one step, not to balance the whole thing. Calculate the molar mass of titanium. You need to include the mass of how many oxygens. So this is 4 O's taken 3 times, and so now you can count them, and there's 12. So that's what this means. And that was designed so that you would actually get the correct molar mass. If we kept adding the titaniums and the phosphoruses together, we could figure out the molar mass. All right, so now we're right back to the mole roadmap or the notes. So let's bring this down. If you started with grams, so now we're going to start with grams. So we're going to start here, right? Grams of A. If you're going to start with 20 grams, then use the molar mass, right, which is what it says we're supposed to do. We're supposed to use the molar mass. And then we're going to use the mole ratio. That would be this one. This is the mole ratio. What would you find? Oh, well, we would have used this step, and then we would have used this step, and we would have been here. We would have been at moles of some other substance. So we'd be at moles of a new substance, right? Then the new substance is not O2, it's something like H2 or O2. All right, so that, I'm going to stop this for a second, but that's the end of the multiple choice. And we're going to use all those ideas to do the calculations in the next section, the mixed problems. So we're in the mixed problems, and the reason we're in mixed problems is, this is like how multiple choice works. All your answers are multiple choice answers because you're going to be getting a multiple choice test. And the idea is to show you that you're going to have to work everything out all the time anyway. So we want to start here. Oh, look at that. Sorry. There we go. Okay, so we're starting here. And then what are we going to do? So I'm writing for the rest of it. We're starting with grams, and we want to find moles, and there's no other substance here. So starting with grams, going to moles is always the same substance. It's a one-step problem. We use the decision tree. We started with grams. We went to moles, but we didn't change the substance. It's one step. Please use the molar mass. Now the molar mass is all these larger numbers at the bottom, just used as grams per mole. That's what a molar mass is. So here we would just multiply. We'd put the grams on the bottom because that matches with that. We'd put moles on top, and we just talked about how these moles are 1 mole. And now we're all done, right? So you have to add all that together. So C is 12.01, and oxygen is 16, and there are 2 of them, so that's 32. So 12.01 and 32 is 44. You really only need whole numbers and maybe the tenths, right? But you don't need to worry about hundreds. So this one is this answer, right? Oh, in the math, 2.2 divided by 44 becomes 0.05. Cool, let's go on. So again, the mole roadmap or the this decision tree help you decide how many steps, and they also provide you with what to do and where to go and what steps to use. So we're going to start with 1.8 moles of S, and we're going to go to moles of Fe. So if you do moles goes to moles and you're changing the chemical formula, which we did, we're changing from moles to Fe. It's one step using the, using the mole ratio, and the mole ratio comes from here. So we're going to take this 3, and it's going to go here, moles of S, and then we'll take this 2, this will be 2 moles. Oh, I can't see that. I don't know how you guys can. 2 moles of Fe. All right, so 1.8 divided by 0.9 times, no, 0.6, sorry, times 0.2 is 1.2. Okay, and you're using a calculator. You don't have to think about it. Okay, so decision tree or mole roadmap. Let's look at this one on the mole roadmap. We're going to mass of one substance from the mass of another substance. That would be 2 steps. That would be start here, that'd be use the mole ratio, and that would be to end up here, the mass of another substance. So 2 steps, molar mass, sorry, mole ratio followed by molar mass. I'm just looking. On this one, we are starting with, or I missed, find the mass. So we're starting with moles, and we're going to mass, and it says it's 2 steps, you start with the mole ratio. Okay, so this one will be 3.2 moles of NaHCO3. And then mole ratio, remember this is where the mole ratio comes from. We'll need that number, and we'll need water. Okay, anything that's not shown is a 1. So we need 1 mole H2O. And down here, it'll be 2 moles NaHCO3. Okay, the second step, we said the second step would be molar mass. I obviously have moles down here, and then I need to get to grams. So this will be grams of H2O. And grams of H2O, I hope you remember this by now, it's 18. So we're going to put that together. Can't do that in my head too well, but it's close to, something feels wrong with this one. No right choices? It must be this one. Hey Siri, what's 3.2 times 18 divided by 2?
3.2 times 18 divided by 2 is 28.8.
There we go. Okay. So one of the things that I'm finding is that just sitting down and going, okay, so what do I need? So we could have, one of the things for the test is you actually sit down and you write these pieces out, knowing that this is what you need to do. I need to have, and you can use example problems where it says the same wording, and you just go, well, I need to have mole ratio. I said it again. I need to have the mole ratio first, and then I got to follow that up with the molar mass. Okay, well, every problem has been like this, right? We've been talking about moles to moles as using the mole ratio. So if you could really sort of drill down to these pieces and go, oh, it's just this. Oh, it's just this. I think that putting it together would actually be easier because you're learning the vocabulary that we're doing right now. If you're just like, I don't know, which one do we do? You're actually not spending much time with the vocabulary. So here's one where I think you just should absolutely just go, oh, I'm going from mass to mass. So what I need to do for this is use the molar mass first, right? And then use the mole ratio. And then I need to switch back and reuse a molar mass. Not the same one, because I'm going to a different place, but a new molar mass. So we have 5, again with the color, 5 grams of C2H2. So I'm going to put grams on the bottom, and it says mole mass. This is the mass part, so I need the mole part on top. C2H2, C2H2. So 24, 25, 26. Yes, I'm rounding. Especially for multiple choice, rounding is completely acceptable. And then I need mole of C2H2. Oops, that's a 6, my fault. 6. So this will be 30. 6. 6. And you know why I noticed? I was looking for the coefficient. Because I need to come up here and go, oh, there it is. I need that coefficient. Okay, so that's the coefficient. Then I need to know where I'm going. So I'm going to oxygen, and I'm using a mole ratio. So I'm switching to oxygen, and that's a 7. It's right there. And then what goes on the bottom? Moles of oxygen. And what do I want to get? I want to get grams of oxygen. And whenever you have grams and moles, the number is 1. And then 2 oxygens adds up to 32. I am assuming you know how to do molar mass. 35 divided by 2 is close to, oh, I don't know, 35 divided by 2. That's what I said. Oh, this is going to be this one, I think. Hey Siri, what's 5 times 7 times 32 divided by 30 divided by 2?
5 times 7 times 32 divided by 30 divided by 2 is about 18.6666.
Right. Okay, thank you, Siri. Okay, we're almost done. What is the mass in moles? And so what I would like you to rely on is that if you know that you're starting with moles and you're ending in grams, that we go over here and I'm starting in moles and I'm ending in grams, and I will need to do molar mass, mole ratio followed by molar mass. And so we're going to write that down so I remember it. Whoops, sorry about that. Oh, look at that. I am in trouble. Moles, grams. So we want to use the mole ratio, and we want to follow it up with the molar mass. The only time we use 3 of these is when we're going from grams to grams. There's no grams to grams, there's not 3 of them. In this one, we're starting with grams and we're going to moles. And so in this one, we'll want to start with molar mass, right? Which makes sense. We need to start with the mass before we use mole ratio. And you have never seen me try to use 2 molar masses in a row. All right. So I'm going to just sort of step through these pretty quickly because I had them set up. I'm writing the Fe2S3 on the bottom because I have little room. But moles of Fe2S3, now this cancels out, goes to a new kind of thing. So I'm going to change my color. 2 moles of, what am I trying to find? Oh, I'm not trying to find anything. I'm trying to stay with the same substance. Oh, so I don't need a mole ratio, right? I don't need a mole ratio because I didn't change my substance. So instead what I need is I need a molar mass. So I'll put moles of Fe2S3 on the bottom, and I'll put my grams of F2S3 on top. Really should have added these together before we started, but it's like 56 times 2 is 1, we're going to say 111, plus 32 times 3 is 96. So 207 about. Hey Siri, what's 0.25 times 207?
0.25 plus 207 is 207.25.
No. Hey Siri, what's 0.25 times 207?
0.25 times 207 is 51.75.
Okay. So that was maybe a good example of estimating and using multiple choice. Not the best way to do it, but okay. Now, this time, I do have to switch to a new substance. So I start with the moles of HCl, and then moles of HCl goes here, and then I'm switching to moles of H2. All right, so boom, 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 boom. This time, this one is 36.5 over 1, and then this comes from the 3 and the 6. So this is 3 and this is 6, which is half. All right. Hey Siri, what's 10.9 times 3 divided by 36.5 divided by 6?
10.9 times 3 divided by 36.5 divided by 6 is about 0.1493.
There you go. So that's how you do all the mixed problems. It gave us a wide variety of different kinds of problems to do. It showed you how to use these. So really you only had to do 1, 2, 3. There's 3 different things you have, 4 different things you have to do. You have to do this one. You do have to do this sometimes if you keep the same substance and you're going from moles to grams or grams to moles. You have to use molar mass all by itself. And then when you do two-step problems, if you start with moles, you start with mole ratio. If you start with mass, you start with molar mass. And then the 3-step one, molar mass. Sorry, did I really do that? Ugh, no wonder people can't believe I did that. Okay, so that's clearly wrong. Ugh. You start with molar mass. You go to mole ratio. And then you go down to another molar mass, which we talked about over and over again. Ugh. Okay. So hopefully that will help you get more understanding of all the different steps in what you're supposed to look for. Maybe not, but it also, like this review sheet has each of the different kinds of problems. And so if you're using each of the different kinds, you just go and find it, and you're just looking for this. Is it moles to moles? Is it grams to moles? And you're halfway there. You just set it up the same way. All right, end of. Okay, this is the honors piece where we're doing limiting reactant, and we're also looking at how to use molar volume, which is the volume of a gas for 1 mole, and then how to do solutions, which each solution has a different molarity that allows you to find things. So I'm going to limit what I'm going to do. Speaking of which, there's also limiting reactant problems here. So we're really focusing on these things right here, this molarity. So this one right here is molarity of HCl, and because it's aqueous, it has molarity. If it's a gas, and I don't say any gases here, then it will say a G, like this, and then we can use this molar volume of 22.4. So I'm trying to get to liters, and I'm starting with 4.8 grams of magnesium, 4.8 grams of Mg, and I am going kind of fast, sorry, because we just spent a long time talking about each of the steps. So what you do is you change to the moles of the substance you're given in the next step. So it's molar mass followed by mole ratio. In the next step, you are changing to the substance you want to get to. So I want to go from Mg to HCl. And then the last step is to change the unit of moles into a unit of liters. So we want the unit of moles to be on the bottom. We want the unit of liters to be on top. This comes from up here. Okay, so we need a 2 and we need a 1. So this will be 1 and this will be 2. All right, excellent. All right, so what do we do here? So your job is to actually dissect this into, this is 0.4 moles in 1 liter. That's what molarity means. In your roadmap, there is an example of what it means, and now you know where the 0.4 goes and what number goes with moles. So sorry, liters. Liters gets 1 when it's in molarity, and the moles is what this is. So there's my calculation. Hey Siri, what's 4.8 times 2 divided by 24.3 divided by 0.4?
4.8 times 2 divided by 24.3 divided by 0.4 is about 0.9876.
Okay, so about 1 liter. That's the only one where I have the molarity reversed. In this one, we have the molarity going forward. So I'm just going to do this one really fast. Now, remember, molarity was my conversion factor. So you start with the liters, and then you use it to change to moles. And molarity and liters, I actually just write them, together, and don't put the substance out until I'm all done with this combination. Of in math often means multiplication, so they almost are telling you how to get this problem set up. We need to reverse. We need to put the HCl on the bottom, and then we need to find out where we're going. We're finding moles of Mg, so moles of MgCl2. And so MgCl2 is 1 and HCl is 2. So this one, 2 goes into this to make 0.2, so 0.2, and 0.5 is 0.1. Why did you stop? I stopped because all I needed was moles. Remember, you go to moles, and then the next step is to change the units, but I didn't need to change the units. All right, the next step is a limiting reactant problem. The limiting reactant problem is to find the smallest value for these two. But I'm going to move on. That's a gram to mole problem, so we're going to skip that. We're actually going to go down here to the second one and work it out and talk about this one. Again, I haven't. So find liters of gas. So we need to get to liters of O2. And you have to do exactly the same thing at the end in this form of a limiting reactant problem. So I need to get to liters of oxygen, which is a gas, right? So this is a gas. And that's important because that's the 22.4 liters in 1 mole. So we have 1 mole and 22.4 liters of O2. Yes, I'm going backwards. And we started with 0.4, again, of another gas. So 0.4 liters. So it turns out that it doesn't matter what gas it is. Each of these gases is 22.4 liters of gas, F2, in 1 mole of F2, just like 1 mole of O2 and 22.4 liters. So it's exactly like any gas, 22.4 liters per mole, and that's why it's called molar volume, because that's what we're doing. All right, so moles of oxygen goes on top, and moles of F2 goes on the bottom, and those values come from up here. It's 1 and 1. So a ridiculously easy problem, 0.4 liters. Okay, so that's one of the 2 choices. This is when I started with F2, which is one of the possibilities. Now, I'm going to have to remember that number. Oh, no, we can keep going. All right, so let's switch colors for a second. And now we got liters again, but they gave us a solution. So this time, remember, we start with the 0.05 liters. We assume the of means a multiplication, which it does, 0.8 moles of H2O2 over 1 liter. So there's my molarity again, 1 liter for each mole that's part of this. So the number goes with moles. Now we got to change from moles of H2O2 into moles of oxygen. And this may not be absolutely apparent, but it turns out that in order to get the same answer, I will need to use the same calculation at the end. The beginning calculation has to be different, but the ending calculation has to be the same. So when I finish this off, I'm still trying to find the liters of the gas oxygen. Oops, liters of oxygen. Okay, and then these values, that's a 1, and H2O2, and that's a 1. Boy, I didn't make that very hard, did I? Okay. Well, that's going to be pretty big. Hey Siri, what's 5 times 0.8 times 22.4?
5 times 0.8 times 22.4 is 89.6.
I didn't do a very good job on that calculation. They're not close. So the limiting reactant is the smallest value. Yes, I'm working right down at the bottom of the screen. So this 0.4 liters is less than 89.6 liters, which makes this the limiting amount you're being made, which makes this, the thing I started with, the reactant that's leading to the limiting amount. So this is my limiting reactant. So 0.40 liters of F2 is my limiting reactant. So that's how you do a limiting reactant problem. You're just given 2 problems that end in the same way. This one took 2 steps, but remember up here, we found the moles. It was a 2-step problem as opposed to a 3-step problem. You can even have a 1-step limiting reactant problem that you can do. And then you just compare them, and you go back to the reactant to see what the limiting reactant is. All right, that's the end of the review.